بسم الله الرحمن الرحيم والحمد لله والصلاة والسلام على سيدنا ومولانا رسول الله وعلى آله وصحبه ومن والاه. So in the previous lecture, we have gone over what are scientific concepts. We discussed their complex nature and their diverse functions in science. In this lecture, we will do the same for scientific theories. This lecture will be based largely on the Stanford Encyclopedia of Philosophy, his entry on philosophy on scientific theories, but I've made changes here and there as I see fit. Okay, so how do I get this to work? Yeah. Okay, so looking at the outline, you'll notice that we have three views of scientific theories: the syntactic, the semantic, and the pragmatic view. We will go over each, discussing core tenets, structure, interpretation, and in certain cases, limitations. So let's get started. In philosophy, we can distinguish three main approaches to understanding scientific theories. These are often seen as competing, yet they offer complementary insight into the complexity of science. Some of these are not exactly competing, but these perspectives can be distinguished by the primary aspects of language that they emphasize, whether it's syntax, semantics, or pragmatics. So the syntactic view focuses on the logical structure of scientific theories, seeing them as sets of sentences within a formal language. This view emphasizes the importance of logical reconstruction and axiomatic systems. Second, we have the semantic view, which shifts the attention from language to mathematical models. It argues that theories are a collection of non-linguistic models, as opposed to the syntactic view, highlighting the mathematical aspects of science. And lastly, we have the pragmatic view, which considers scientific theories as complex entities embedded in scientific practice, encompassing not only sentences in models, but also exemplars, skills, and values. This view prioritizes the function and context of scientific theories. Now, as I've said earlier, these three views are not necessarily mutually exclusive. It will be, hopefully it will be clear by the end of this lecture that the pragmatic view is able to integrate many aspects and sometimes entire views in its own conception of scientific theories. But for that to be clear, we'll need to get to the pragmatic view. Let's start with the syntactic view. So the syntactic view, also known as the received view, because at one point it was really the dominant view, the received view, during the age of the logical positivist. It emerged from the works of the Vienna Circle, logical empiricism or positivism. This perspective argues that the philosophy of science should be primarily concerned with the logic of natural science. So the core tenets of this view is theory is an axiomatic system. The central tenet of a syntactic view is that a scientific theory can be reconstructed as an axiomatic system using the tools of meta-mathematics such as predicate logic and set theory. This reconstruction involves expressing theories as sets of sentences in domain-specific logical language. We'll explain that in due course. Second, the importance of logical language. So the syntactic view places a great deal of emphasis on using robust and clear logical language for this reconstruction. These languages include the language of physics, anthropology, or other scientific disciplines. Thirdly, we have focus on syntax. The primary focus is on syntax, or grammatical structure of language and its relations, rather than semantics or meanings of language and how it's used in real-world situations. So let's go to the structure of scientific theory on the syntactic view. We start with terms. This is the vocabulary of a scientific language. It is divided into three kinds of terms: the theoretical, the logical, and the observational. So theoretical terms refer to unobservable entities like molecules or protons. Logical terms include quantifier, such as all or there exist. and connectives such as and or if then. Observational terms refer to observable entities and properties such as hard, blue, hot, what we can observe. From terms, we move to sentences. And terms are combined into three types of sentences. We have theoretical sentences, correspondence sentences, and observational sentences. Theoretical sentences, TS, include the axioms, the theorems, and the laws of a theory. Correspondence sentences link theoretical sentences to observable phenomena, providing an interpretation and application. These are often called bridge principles, coordinative definitions. There are different wording for this. Thirdly, we have observational sentences, OS, which describe observable states of affairs using only observational and logical terms. Now, let's look at language. The domain language of science consists of two languages, the theoretical language and the observational language. Both include logical terms, but the theoretical language has theoretical vocabulary, while the observational language has observational terms. The theoretical language is further constrained by the logical calculus that governs the axiomatic system. So, in short, the structure of a scientific theory from a syntactic perspective can be summarized as follows. So we have a theory, we have a link, we have observation. We have different types of sentences, terms, and language. So in a theory, we have theoretical sentences. The terms involved in a theoretical sentences are theoretical terms and logical terms. The language is a theoretical language. The link, which is very important, involves correspondence sentences. Correspondence sentences include theoretical, logical, and observational vocabulary or terms. And the language here is theoretical language and observational language. Lastly, we have in observation, we have sentences, observational sentences, and these include observational terms and logical terms. And the language used here is a observational language. Okay, so it's important to note that on the syntactic view, there is a salient divide between theory and observation. Scientific knowledge is viewed as existing on three levels. So we have TS, which we said is the theoretical sentences. It is the uninterpreted syntactic system of a scientific theory. Next, we have the theoretical sentences and the correspondence sentences. This is the theory structure of a particular domain, including the connection to observation. And lastly, we have the theoretical sentences, correspondence sentences, and observational sentences. And this is the complete science of a particular domain, which includes observation. A key feature of this is the distinction between theoretical sentences, correspondence sentences, even though they're both part of the structure of a scientific theory. So how is this interpreted? Okay, so the crucial link between theory and the world, according to the syntactic view, is provided by the correspondence rules, which are expressed in correspondence sentences. These rules have been given different names by different philosophers, such as dictionary entries, operational rules, coordinative definitions, reduction sentences, bridge principles, bridge laws, what have you. The central function of correspondence rules, however, is very important. It is to interpret the theoretical terms by connecting them to observational phenomena. Interpretation is, by interpretation, we mean correspondence rules provide the observational interpretation for the abstract theoretical component of a theory. So we have a theory, it has an abstract component. We want to link it to observation. We want to link it to the world. And this is what correspondence rules or correspondence sentences do. They connect theory to the world. They are essential because axiomatic systems of physics cannot exist, to use Carnap's word, in the splendid isolation from the world. So what are the limitations of the syntactic view? Despite its emphasis on logic and rigor, the syntactic view has faced several criticisms. One, the rigidity of the logical language, which is the reliance on first-order predicate logic. It can be, according to these critics, too inflexible and limited for capturing the full complexity of scientific theories. And this will be highlighted when we discuss on the pragmatic view. Second, we have the problem of individuation. Since theories are defined by their linguistic formulation, any change in formulation creates a new theory, even if the underlying content is the same, since it's really language-based. Three, we have the artificiality of theory/observation distinction. The strict division between theoretical and observational language may not reflect scientific practice. For instance, observability may pertain to entities rather than to concepts. Fourth, unintended models. So there is a difficulty in distinguishing between intended and unintended models of a theory. Fifth, we have a confused correspondence rules. So correspondence rules, in some perspectives, are considered a mix of meaning relationships, reductions, claims about causality, and means of theoretical concept testing. So it's not clear what exactly are correspondence rules. And lastly, we have practical limitations. Not lastly, okay. And we have practical limitations, which this approach, while syntactically correct, isn't considered to be useful in most areas of scientific research. This would actually be said also of the semantic view. We'll get to that in a few. Now, lastly, we have neglect of practice and history. So the syntactic view often neglects the practical and historical aspects of scientific theorizing and experimenting. Now we move to the semantic view. The semantic view emerged as a response to the perceived limitation of the syntactic view. This perspective argues that the proper object of analysis should be mathematical models used in science rather than formal language. So what are the core tenets of the semantic view? Well, a focus on models. Scientific theories are conceived of as collection of mathematical models, not as set of sentences as in the syntactic view. The view emphasizes the mathematical structures, functions, and relations of scientific theories. Second, we have mathematics over metamathematics. It argued that mathematics, not metamathematics, is the correct tool for philosophy of science. Metamathematics is seen as overly concerned. This is the tools used in syntactic view. It's seen as overly concerned with formal linguistic structure instead of what the semantic view claims is the actual mathematical structure of a scientific theory. And thirdly, we have the importance of mathematical structure, if it's not obvious by now. The semantic view suggests a shift away from language and towards mathematical objects. Now we have two approaches within the semantic view. There are two strategies for characterizing theory structure within the semantic view. I will not go over these in any details, as I'm not an expert on the semantic view. And I also do not think that there's anything substantive that hangs on understanding the details of this view. So it's helpful to give an idea. So we have the state phase or state space approach. This approach identifies theory structure with a class or a family of mathematical models. A key component of state space modeling is phase space, where every variable in the theory corresponds to a dimension, and each point represents a potential state of a real system. Laws of theory describe the system's trajectory through state space. Examples include law of succession, law of coexistence, laws of interaction. And the second is the set or model theoretic approach. This approach uses set theory and model theory to formalize mathematical structure or theories. Set theory acts as a general language for describing mathematical structures. Model theory investigates how formal axioms relate to mathematical models and provide interpretations that make the axiom true. Model theory often uses set theory, which can in turn be extended to link axiomatic theories to semantic models via set theoretic predicates or set theoretical predicate. There's also hybrid approaches using partial structures and what. So let us look at how a theory is interpreted based on the semantic view. The semantic view proposes different ways to analyze scientific theories and relate them to empirical phenomena. It distinguishes the individuation of theories from the relationship to both phenomena in the world. So we have individuation and the relation to both phenomena in the world. These approaches, the theory interpretation, are worth investigating. So one of the most famous interpretations is the hierarchy of structure. According to this interpretation, the relationship between theory and data is a hierarchical one. This includes a model of a theory, a model of an experiment, and model of a data, or the data. So we start with axioms of a theory. These define set theoretic predicates and form the basis of scientific theories. These are the axioms. Second, we have a model of a theory, what is also described or termed representation theorems. They determine if a subset of a model can be isomorphic to all of the models for the theory. And thirdly, we have models of experiments. And these are the experimental designs that inform the setup and analysis of experiment. There are complex relations between models of experiments and models of a theory, measurements theories, and data models. And lastly, we have models of data. Data is organized statistically in the context of theoretical models with choice for what parameters to represent. So one key point is that the relation between data and the theory is not a straightforward one. So let's give an example. A motivating example that helps to understand the theory and model is a 7-point geometry, also known as the Fano plane. The axioms of the projective plane include, for any 2 point, exactly 1 line lies on both. For any 2 lines, exactly 1 point lies on both. There is a set of 4 points such that no line contains more than 2 of them. A geometrical figure can be drawn, satisfying the axioms where the model interprets and makes true the axioms and theorems. This model includes 7 points and 7 lines and can be embedded in a Euclidean plane. This shows how a geometric model can provide a semantic for the axioms of a theory. I mentioned here only the hierarchical view of the hierarchical interpretation of model, but there are other approaches of interpreting theory on the semantic view, which I will not go over. Lastly, we go to the pragmatic view. Now, the pragmatic view recognizes that a number of assumptions about scientific theories seem to be shared by both the syntactic and the semantic views. Both perspectives, for example, agree very roughly that theory is explicit, mathematical, abstract, systematic, readily individualizable, and distinct from data and experiment. And finally, highly explanatory and predictive. Now, the pragmatic view imagines the structure of scientific theories rather differently, arguing for a variety of theses. And we will look at these in turn. First, we have limitations of idealized theory. So, idealized notion of theory might be inadequate to account for the predictive and explanatory work expected of them. We will say some more on that later. 2, we have pluralism about theory. So the pragmatic view sees theory as plural and complex, with internal variation existing in different types. These include internal pluralism or variety in-theory components, such as values, analogies, and whatnot. And external pluralism, different types of theories. We have different types of theories like mechanistic theories, historical theories, mathematical theories. 3, we have non-formal aspects in theories. Remember that both the syntactic and the semantic views are formal aspect, or formal, what you might call it. They're formalized theories. But the pragmatic theory emphasizes that, or highlights that, there are certain aspects which are not formal. This view emphasizes the importance of non-formal aspects such as metaphors and analogies, values, and policy views in theory construction. These aspects may be implicit or hidden. 4th, we have function and purpose. So the pragmatic view believes that the way a theory is characterized and how it changes depends on the users, their goals, and their values. And 5th, we have a continuity with practice. Theory structure is continuous with practice and the experimental life, making it difficult to neatly dichotomize theory and practice, which the syntactic and the semantic view do. Now, given the limitations imposed on, or more precisely recognized of, both the syntactic and the semantic view of theory, the pragmatic view introduces another key component, which is, which are models. So we will briefly discuss models and their role, but we'll also discuss theories. Here, to avoid confusion, it is helpful to distinguish between theories as understood by the syntactic and the semantic view, and theory on the pragmatic view. For proponent of the pragmatic view may still use both in different ways. So they may accept theories of a syntactic view not as real theory, but as principles. And when they're using the term theory in a strict sense, they generally mean their more liberal, less formal understanding. So the pragmatic view and models. Let me just change the place of. Okay, given that idealized high-level theories are unable to do the explanatory and predictive work we want of them, see tenet 1 in core principles, core components of the pragmatic view. Proponent of the pragmatic view urged that we choose models and not theories as the unit of philosophical analysis. Abstract theories are also empty. They need to be concretely realized in messy real-world situations. Their concrete realization, however, is not through simple derivation, but through model building. And there is no recipe for that, which involves or invokes the other four tenets, 2, 3, 4, 5. So, yeah. Okay, so now we move to the pragmatic view of theory. The pragmatic view of theory has the following characteristics. We have resistance to the traditional characterization of theory as explicit, mathematical, and abstract. 1. 2, non-formal patterns. So theories are also characterized by non-formal patterns such as organization and composition. For example, we have a mechanistic theory includes patterns such as organization in series, parallel, and cycle. 3, on content. Content of a theory is context dependent on the pragmatic view based on the investigation undertaken. For example, assumptions used by scientists are sometimes more important than ones they believe to be true. So they make certain assumptions to make sure the model works. These assumptions are not part of the theory. These might be described as contextual assumptions that are made on the go. These are important because they make the model work. And 4th, the pragmatic view extends theories beyond words and formula to include machines, techniques, experiments, and applications. In a word, whatever that helps the model work is relevant. We cannot ignore these. We have to take them into account on the pragmatic view. We also have emphasis on know-how. The pragmatic view also stresses know-how and creativity in scientific practice. And assumptions. The pragmatic view expands notion of theory to include ontological assumptions and conditions of application or scope. And modes of theorizing. It also explores pluralism in modes of theorizing and ways of analyzing theoretical structure. This includes recognizing of various styles of scientific reasoning, including the historical, the mechanical, and the mathematical. And lastly, units of analysis. There is a recognition of a need for philosophical utility of various proposed units such as Kuhn's paradigm, Lakatosh's research program, Loudon's research tradition, and Holton's themata. So in a word, the pragmatic view really is concerned about science in the earthly plane. In other words, science in the here and now. It does not really care about science in the abstract, because at the end of the day, whether science is being tested or is being used to explain something, it will be done in a concrete situation. So unless you can make the case that your theory works in a concrete situation, or the structure that you have, or conception of a theory that you have works in concrete situations, then it's useless. That's why the pragmatic view emphasizes all these messy things that needs to be taken into account when constructing a theory or / model. Okay, so interpreting a theory structure on the pragmatic view. So the pragmatic view, as should be clear by now, sees theory interpretation as tightly linked to or connected to practice, purpose, and the function of a model and theories. So we have purpose and intentions. Interpretation is deeply influenced by users' intent, purpose, and values. This contrasts sharply with the abstract and decontextualized approach taken by other views. The relationship between model and the world are contingent on questions being asked and the relevant criteria chosen for the various available options. And we have theory confirmation. Criteria for theory confirmation, if we accept theory confirmation, includes not only predictive power and empirical adequacy, but also pragmatic virtues such as fruitfulness and utility. And thirdly, function and practice. Scientific theory is shaped by and constrained by its intended purpose and how it is practically applied. So to conclude, in summary, there are 3 views of what scientific theories are. Each offers a distinct lens through which to understand how science works. The syntactic view prioritizes logical reconstruction, seeing theories as axiomatic systems of sentences. The semantic view focuses on mathematical models, viewing theories as collection of these models. And the pragmatic view, with its emphasis on embeddedness of a theory in practice, and acknowledging the role of context and function, presents a particularly valuable approach for understanding how scientific knowledge is created and used. It acknowledges the complexity and messiness of scientific process, moving beyond the idealized picture that may be presented by other views, but this does not prevent it from utilizing either the syntactic or the semantic approach to capture a certain aspect of a theory, structure, or interpretation, all the while denying that this approach exhausts the whole of what a scientific theory is or can do. And that's it.